This lecture we were started just discussing about rotating machines, how the concept of rotating machines can be built up mentally. Okay, this is the thing in linear thing, therefore, in a confined place if I want to repeat that thing. So, a rotational machine is necessary, and I was drawing. Let me draw several times, it does not matter. I will draw it somewhat slightly nicer way. Suppose this is the every rotating machine is having some stator and rotor, and this is the stator irons which is cylindrical, and there may be coils wrapped around the poles, and later we will see there are several other possibilities, but to just, and if you pass current like this becomes a north pole of the stator, because lines of force will come out, and this will become south pole of the stator. The part which moves is also cylindrical with common center with the stator and the rotor structure. Center is common like this, and it has got a shaft, and there you can make some slots. A pair of slots I have taken which are diametrically opposite, which will ensure if at any time one slot is under center of the stator pole, other slot will be under the center of the north pole. That is these slots are separated by a slot pitch. The term slot pitch I have never used till now, but it is very simple to say. If you see the developed diagram of the machine, that is, think you have cut it and like this and unfolded it in both the sides, it will simply look like this. And suppose this is south pole, this is north pole, stator iron, this part is this part, and in the rotor there is a single slot, and since the rotor can move, this is all iron. You cut it with a scissor, will not be able to cut an iron, but what I am telling, think, okay, it is, you have cut it and unfolded it, it will be like this, and there is another slot here, you will see slot say 1, slot 1 dashed, if you call it, okay, 1 dashed, these two conductors are there, and this fellow is allowed to move. This fellow is allowed to move. Now, the distance between this center of the south pole or center of the north pole is called one pole pitch. Pole pitch could be, obviously, this distance is also a pole pitch. This to this, same thing, pole pitch, or center of this and center, because it is circular. So, once again you will see north here. So, center of this and center of this is also one pole pitch. That is, from this to this, if you go, okay, you have finished south pole. From this to this, so pole pitch is this. Therefore, to maximize the induced voltage, it is always better to put one coil side or conductor, if it is at any time under the center of the south pole, the other coil side should be under the center of the south pole. This is moving, I have shown it in the arbitrary position. So, as it moves, you can see this, if it is center here, this is also one pole pitch. Okay, the reason for placing the two coil sides under the one pole pitch apart I have explained earlier, but this is how I have done. That's why diametrically opposite I have put. Now, what I am telling that in general, when it is operating as a motor or a generator, these rotor conductors will also carry current. Therefore, rotor conductors too will produce field, magnetic field. For example, if I say that rotor is carrying current in this direction, this is cross, this is dot. Okay, this conductor is carrying cross, this is dot. How this conductor is carrying current? Because we have seen if it is motor operation, this you must have been excited by a source of voltage. Suppose at a given instant of time, this is carrying current. Therefore, if it carries current, it will produce lines of forces like this. Is not? This is the rule, cross this way. So, this will produce a field, and if it produces a field, therefore, rotor carrying current ultimately produces a magnetic field. And if I ask you where is NR, where is SR, south pole of the rotor, this is the rotor, north pole must be here, I must say this is NR. Why? Because lines of force are emanating from it, and south pole will be there. The point I am trying to driving at is to think always in this way, that okay, in any rotating machine there will be a stator structure, it will house a windings, and those windings will carry current. Therefore, they will produce a field pattern south SS, NS, etc. Similarly, rotor will have slots, and they will be also carrying current, no matter whether it is operating as a motor or as a generator, they will carry current, and they too will be producing their own NR and SR. And then I will say that okay, now ultimately you have got a set of pole existing on the stator structure which does not rotate, and you have a set of poles on the rotor iron body. This is rotor iron, one side has become north pole, another side has become south pole, and I will simply argue like this, okay, these two sets of magnet then will interact and give you force. For example, in this particular case you can easily see this NR and SS, this NR is free to rotate, therefore, it will experience a force in this direction, and similarly this SR experiences a force in this direction, and therefore, there will be a torque applied to this whole rotor body, and rotor will try to spin in the anti-clockwise direction in this particular case. Understood? This is very, that way you look at the things, okay, it will produce a field like this. For example, you switch on your ceiling fan in your sitting in your room, you switch on the supply, what you will see? You will see the rotor of that fan motor is accelerating initially, and then finally it is settled to certain speed. How do I explain this phenomena? without knowing much. Knowing this much, I will say, okay, that motor must be having a stator winding which is carrying some current, and it has produced some field NS, SS like that. Rotor must be also having some coils or conductors in it, and it is also carrying some current. And because why they are carrying current? Because I have switched on the supply, they are supposed to carry current. Rotor 2 will carry current. Rotor 2 then will produce NRSR, and it is ultimately this NRSR reacting with SS and NS has produced some electromagnetic torque, and that is why the machine is running. During the transient process, when it accelerates, things changes with time, velocity is not constant there. But eventually you will observe, it is just observation, it is running at a constant speed, and therefore, I now know, suppose this is the rotor of that motor, I do not know in detail what is inside that motor, but with this argument I can say several things, that is NRSR has been produced, NSSS has been produced, and it is running at a constant speed, and the interaction of this SS, NS and NRSR gives you electromagnetic torque. And if somebody says it is running at a constant speed, I will demand that on the shaft there is some opposing torque present in the form of friction. Your blade of the motor has to run against wind. So, that is the opposing force. These two, initially there was imbalance in these two, that is why machine accelerated with some RPM n, and eventually if it is running at a constant speed, my conclusion will be electromagnetic torque in the steady state developed by the motor, who creates T, the interaction of NRSR and NSSS. What is T opposition? It is existing in the system, or maybe you are doing some mechanical work, suppose the motor is running a pump, things like that, opposing force against which you have to turn the motor. Direction of rotation is set by T, direction of T will decide in which direction the motor is going to run. And at steady state, T must be equal to T opposition. Machine will do find out its own steady state operating point, as we have seen in case of a single conductor generator. Therefore, this is the scenario. It happens in every machines. For example, DC machine, 3-phase induction motor, synchronous motor, no matter what is this machine is, such a thing is going on happening. What is such a things? That is, there must be a stator body, there must be some stator windings, coils. It may not be the stator coils of this kind all the time, we will see various of them later, but essentially there will be some coils or windings on the stator, there will be some coils or windings on the rotor, and it is they are supposed to carry currents. The moment a coil carries current, it produces a pair of poles. If the poles are on the stator, we say okay, NSSS. If the pair of poles are on the rotor, NRSR. Who has created this? These currents, cross dot. And I should be in a position to clearly put the arrows of the lines of force, and then it is so simple to understand in which direction rotor experiences a torque, and it will start moving. Understood? This is very important. Acha, now a slightly a neat diagram I will produce. For example, you can now think that stator, I have till now shown some projected poles, but I can make a stator like this. Totally cylindrical, annular. I mean, these are iron, and it has got a length perpendicular to the paper. It goes around. So, iron, made of iron. Now, I can say have, instead of projected poles like this, I can cut slots here, and here is another slot. So, this is the stator, only a pair of slots. There is nothing here, it is open, a groove, and there I can place a conductor, and here also I can place conductor, two conductors, and at the back I have joined them like this. This is suppose x 1, y 1, this is suppose x 2, y 2, and these two are joined. And in front of you, two terminals are available to you for playing. I mean, to get voltage or pump current into this coil and so on. Now, suppose you excite this coil by a battery, connect a battery across x 1, x 2. Try to understand some voltage, DC suppose. Therefore, current will flow like this, and if this current flows, then in this diagram I must show it in this way, cross and dot in this sectional diagram. You must have a clear idea of this thing and this thing. Current is flowing like this, so it will go. I have not drawn the rotor yet, just to understand, trying to understand how the things goes. Therefore, once it is done, stator is carrying a current and it will produce magnetic field, as you can see, like this here. There are several exercises given in your tutorial 0. Please go through that and you will be often using that. So this is the thing, this is how the lines of force. Incidentally, magnetic lines of force will be closing onto themselves. So, this will be the lines of force it will be created, and there will be several of them. You must understand, dot here, this is cross current. Locally, if you see, it will be like this, there will be here, and all the lines of force close onto themselves. Now, there is a stator here, you have excited the stator coil only, and this will be the field pattern. If it is a fixed current, this pattern will remain there and it will be like this. Now, the question is, this stator iron has now become a magnet. Now, where is its north pole? Where is its south pole? As I told you earlier, lines of force terminating on the iron part is your south pole. So, your SS will be here, and this SS exists here also, that is, half of this stator structure will become south pole. In the same way, this inner surface of this stator iron will behave like a north pole, because lines of forces are coming out from it, NR, and lines of forces till this point all are coming out. So, this will be NR. So, half of the stator body becomes south pole and half of the other half becomes north pole. So, this will be your NS, NR, NS. This S stands for stator. Therefore, the stator structure need not be like this all the time, but it could be like this also. You can create stator south and north pole. Now, the question is whether the strength of this south pole here is constant around it or is varying in nature. Those things we will discuss later, do not worry about that. But essentially these are the things I can figure out, okay, nothing other than this can happen, that is all. And on the top of it there may be this rotor coil. Rotor too will have slots, they can carry current, it will create NR/SR like this. Similarly, rotor could be also projected poles. You have understood the point I am trying to driving at, that is the projected poles configurations may be also on the rotor and things like that. We will see now what is what. So, now what I am going to discuss after having these preliminary ideas of the things which constitute a motor, a stator, there will be several slots, there will be conductors, they will carry current, but eventually the end result is they will create a pair of poles. Similarly, rotor will have some iron body on which there will be rotor conductors, they will also carry current, they will also produce a pair of poles. And these magnetic poles produced by stator coils and produced by rotor coils, they will interact you and give you torque. Now, we will discuss for a general the common underlying principles. This let me write common underlying principle of operation of common underlying principle of operation of electrical machines, electrical rotating machine. At least one condition is very easy to understand. Now, what I am going to show you is this diagram, you just look at. Okay. It is a stator iron. I have, for clarity, I have not drawn the coils. There will be slots here this side, there this side, and I will pass some current, and half of this will become south pole, half of this north pole. That is understood. This is the stator iron, this portion, and this S and N has been created by stator conductors, which I have not drawn here, and it carries current and there will be field here. Now, similarly, forget about this projected pole business, I will put it like this, the way I have drawn. Okay. I have drawn like this stator. Okay. Here is a slot, here is a slot, I am pushing current this side cross, this side dot, so that lines of force will be like this. Now, suppose you have a rotor body. Rotor body will be placed like this here. Forget about this projected poles. Imagine this project, it is no projected poles. Projected poles also it is fine, it is just like this here, and this rotor can rotate. Okay. So, suppose arbitrary position it is there. You also notice this part can rotate, this part is stator. There must be some air gap in between, that is this portion. This portion, uniform air gap will exist in any rotating machine. So that rotor can freely move, it should not strike the stator iron parts. So, for smooth rotation there must be some air gap, you cannot avoid that. So, a stator, rotor and this one. How this rotor field could be created in this direction? Rotor may be having some conduct coils here, some coils here in these slots, and if you cross current here, dot current here, cross current here, dot current here, it will create a north pole. North pole is on the outer surface of the stator, south pole is outer. These are SR and NR, mind you, and this is, if you allow me, I will write SS, NS, and this is SR and this is NR. Understood? So, this is the thing, and this will happen in ultimately whatever complex windings you are using, projected pole or not, it does not matter. Essentially what we are talking about, stator conductors will carry current, rotor conductors will carry current, and they will produce a pair of poles like this. And if it is in this position, as you can see, rotor, suppose I am holding it by hand, the pattern of the poles are like this, then this fellow will definitely experience a repelling force here, this fellow also repelling force, and it is experience a torque in this direction, it will try to move. We will continue this in the next class.